Hello, another unit circle lesson in pre-calculus. So today we will be using the unit circle. Yesterday, or in the previous lesson, whenever you did it, you would have made a unit circle, and that counted as your assignment. Now we're actually going to use it, and we're going to use it much in the way that you would use a calculator. It's a tool. You're asked a question, you reference it, and it gives you the answer. Recall that any point on the unit circle gives you trig values for the most common angles. So a point on the unit circle, any point is an xy coordinate, works out to be a cosine and sine value. So y is always a sine value, x is a cosine value. You can extend that and get y over x to give you tangent, and then you can flip them all over, take the reciprocal of each one to get the other trig functions, cosecant, secant, and cotangent, which are often referred to as the reciprocal functions because they are the main three flipped over. Remember, if you have a variable like y and you flip it over, you put a 1 under it. That way when you flip it, it becomes 1 over y. So that kind of explains the 1 over y, the 1 over x here. Okay, that's enough of that. We're ready to go. So, using the unit circle, find the exact value of each trigonometric function. I'm going to do the evens. Of course, I ask you to do the odds. What's the cosine of 0? Well, I can't use the unit circle if I don't have the unit circle. So there's my unit circle. And here's my homework. So here we go. What is the cosine of 0 degrees? 0 degrees is right here. Cosine is the x value. The x value is 1. That was easy. Do I need to check it? Number 2, the answer is 1. Sine of negative 315. Uh-oh, now wait a second here. Negative 315. All of a sudden it got bad. There's no negative angles on here. Okay, this is where you got to take some of your prior learning. So if 315 is, oh, I can't draw on this. If 315 is here, negative 315 goes the other direction. Oh, I really want to be able to draw on that. This is going to drive me nuts. Let me do something a little bit different here just to make the homework go a little bit easier. So something I can do with Notability is I'm going to add a page, and then on this page, hit the plus sign. I can go to the photo library, recently added photo, and get that, and there it is. So now I can write on it. I just got to scroll up and down. Let me move it down a little bit so it's not quite so bad. Enlarge it a little bit. There. Okay, so number 4, the sine of negative 315. Well, let me do a different color so it stands out a little bit better. 315 is here. Negative 315 goes the opposite direction and would take me here. So 45 is the same thing as negative 315. So that's a quick little thing. We did coterminal angles already, so you could calculate that. But square root of 2 over 2, square root of 2 over 2, and we are doing sine. Sine is the y value, so that is square root of 2 over 2. And I guess all my writing is going to be in red for the rest of this paper. So number 4, is it square root of 2 over 2? It is. Let's look at the secant of 60 degrees. So 60 degrees is right here. Secant is the reciprocal of the x value. So the x value is 1/2. The reciprocal of 1/2 is 2 over 1, which is just 2. The secant of 60 degrees is 2, and there it is. Cosecant of negative 300. Okay, we have another negative angle. So positive 300 is right here, which is 60 degrees off of the x-axis. So negative 300 goes this way to where it's 60 degrees off the x-axis. So we're doing basically, negative 300 is the same thing as 60. And what are we doing? Cosecant. Cosecant is the reciprocal of the y value. So it's the reciprocal of the y value, 2 over the square root of 3. And then we have this rule about not being allowed to have radicals in the bottom of a fraction, right? So we got to do this little deal. And then the square root of 9 is 3. 2 radical 3 over 3 should be the answer for number 8. And it is. Now, if I were to grab Desmos and type in cosecant of negative 300 degrees, what would it give me? Well, it would give me the decimal approximation of 2 square root of 3 over 3. It would not give me the exact answer. So this is a way in which the unit circle is a little superior to a calculator. That being said, if you did secant of 60 on a calculator, because 2 is a whole number, it would give you 2, and that would be just fine. So I want you to learn how to use the unit circle. You could do a lot of this on Desmos or any calculator, but they would not give you the radical answers, which is what we're looking for. And did I check number 8? Where am I? Oh, yeah, I did. Okay. Number 10. Sine of 5 pi over 3. Okay, now this is in radians, but that's okay. Our unit circle is in radians. We got to find, let me erase all this, 5 pi over 3. 5 pi over 3 is where? Right there. So that's a 300-degree angle. 5 pi over 3. And we're supposed to find the sine. Sine is the y value. So that's negative square root of 3 over 2. Let me check number 10 and make sure I didn't screw up. Negative square root of 3 over 2 right there. All right, tangent of negative pi over 2. So, okay, negative pi over 2. Positive pi over 2 is a 90-degree angle. Negative pi over 2 would just be the other direction. So right here. Tangent, again, check our notes. Tangent is y divided by x. So I need to take the y value, which is negative 1, divided by the x value, which is 0. Negative 1 divided by 0. But wait, in mathematics, you cannot divide by 0. This is referred to as undefined. So apparently, there is no tangent value for negative pi over 2. Let's check the answer key. And agreed. So if you were doing that on a calculator, it would give you error or undefined. Number 14, cosecant of 5 pi over 6. All right, let's find 5 pi over 6 on the unit circle. Let me erase a lot of this extra stuff. Where is 5 pi over 6? Right there, which would be 150 degrees if you care. And we are doing the cosecant. Cosecant is 1 over y, or the reciprocal of y. So I need to take this y value and reciprocate it, or flip it over. So 1 over 2 becomes 2 over 1, which is just 2. So number 14, the answer should be 2, and there it is. So do you see how this works? Locate the angle on the unit circle, see which trig value you're supposed to do, check your notes if you need to, and then you get your answer. And if there happens to be a radical in the bottom, you got to rationalize it, like this one. Or if there's a 0 in the bottom, it's called undefined. All right, number 16. So cotangent of negative 7 pi over 6. So 7 pi over 6 is right here. That's the positive angle. The negative angle would be the same amount in the other direction, which would take us there. So that's this angle once again. And we're supposed to do the cotangent. Cotangent is x divided by y. So I need to take this x value divided by that y value. Negative square root of 3 over 2 divided by 1/2. Now, that's a messy thing. How do you simplify that? I'm going to quickly explain 2 ways to simplify this. This is a complex fraction, a fraction within a fraction, or 2 fractions within one larger fraction. The denominator is 2, and one thing you can do is just simply multiply by 2 over 2. That makes this cancel. You get negative square root of 3. This cancels over 1. Negative square root of 3 over 1 is just negative square root of 3. and there's the answer. I said I was going to explain it a couple of ways. That's one way. So you multiply by 2 over 2. The other way to simplify it I think is much easier, but it's kind of harder to explain, and once you get it, it's like, wow, that was simple. Let me give you some basic algebra. If you had 5x over 5y, you know to cancel out those 5's and get x over y, right? Or if you have 3x over 7x, you can cancel out the x's and get 3/7. In other words, if you have the same thing on top and bottom of the fraction, they cancel. Well, what about this answer? We have the same thing on top and bottom, half and half, right? If you have the same thing on top and bottom, they cancel. So the half cancels with a half, gives you negative square root of 3 over 1, which again is just negative square root of 3. So a couple of ways to simplify that one if you need to. All right, so 1 through 15 are going to be a lot like 2 through 16. You got some negative angles in there you're going to have to figure out a little bit, but it's all stuff you can do. The second page is a little different. You're actually given the trig value, and you're supposed to find the angle that goes with it. So let me explain with number 18 here. Cosine of theta equals square root of 3 over 2. Now remember, on the unit circle, cosine is x. So we want to find any angle in this diagram. Let me erase all these extra marks. Any angle in this diagram that has an x coordinate of square root of 3 over 2. So let me use the highlighter. Where is an x coordinate that's square root of 3 over 2? Well, right there, right? 30 degrees. But also this one, right? 330 degrees. So there's actually two angles on the diagram that have an x coordinate of square root of 3 over 2. You might say, oh, what about this one? No, that's negative square root of 3 over 2. Same thing for that one, negative. The problem only has positive square root of 3 over 2. But nonetheless, there are two answers. And that's what this means. 0 less than or equal to theta less than or equal to 360. That basically says give all of the answers on the unit circle. 360 is a full circle. You can do other problems where they only want one answer, and they might say only give the answers between 0 and 180, and then you're only supposed to give the first answer but not the second answer. Don't worry about that. You're going to give both answers in these problems. So I don't put an equal sign here. For this problem, theta is going to equal, what were they again? Not these two, those were negative, 30 degrees and 330 degrees. So theta is either 30 or 330. Let me check number 18, make sure I did it right, and good. Number 20, sine of theta equals negative 1. Sine on the unit circle is a y value, so we're looking for any y value in the diagram that equals negative 1. Well, that only happens once right there, and that's a 270 degree angle. So that is theta equals 270 degrees. And honestly, I caught a glimpse of that answer before I even started. Feel like you're getting it? And you don't have to worry about any negative angles here. That's kind of good. All right, cotangent equals 1. Now this is a little tricky. On the unit circle, cotangent is x divided by y. So we're trying to find x divided by y equals 1. How can you wrap your brain around that? How's that going to work? Well, keep in mind, in order for a fraction to equal 1, the numerator and the denominator have to be the same. So we want to find points on the graph where the x and y coordinates are the same. So let me erase a bunch of this. All right, what coordinates on this chart have the same value? It should happen twice, right here. Square root of 2 over 2, square root of 2 over 2. If you divide those by each other, you get 1, right? 1. So that means theta is 45 degrees. Isn't that where that happened at? 45 degrees, yep. But there's a second time that it happens. Not here, because one's positive, one's negative. If you divide them, they still cancel each other out, but that gives you negative 1. But look down here, negative square root of 2 over 2, negative square root of 2 over 2. If you divide those, not only do they cancel, but the negatives cancel and give you 1. So that happens at 200, I got off a little bit, 225 degrees. So two answers here, 45 and 225. Let's check. There it is. The next one is a tangent, which is the same idea, but we want to find, now this is going to be really tricky. So tangent is y divided by x. We need to find a y divided by x that equals negative square root of 3 over 3. Does that mean y equals square root of 3 and x equals 3? No. None of the points up there work like that. So what the heck? So let's go up and look at our options. First I got to erase all my scribbles from the previous problem. So we're doing tangent, we're looking for a y divided by x that equals negative square root of 3 over 3. First of all, we're only going to pick points that have a square root of 3 in them. So it could be maybe this one, or maybe that one has a square root of 3 in it, but no square root of 3 in there, not in here, not in here, not in here. Oh wait, sorry. That one does have a square root of 3 in it, right? Right there. So it could be that point. Definitely not this one. Could be that one. Definitely not that one, not that one, not that one, not that one. So I've narrowed us down to 2, 4, 6, 8 possible angles. But our answer is going to be a negative. It can't be anything in this quadrant because a positive divided by a positive equals a positive. And in this quadrant, we've got two negatives. A negative divided by a negative equals a positive. So it can't be either of those. So now I've got it narrowed down to 4 possible answers. Now I'm just going to guess and check. I'm going to take y divided by x in each one of these points and see what happens. So let's take this first one. X. Y divided by x is going to be square root of 3 over 2 divided by negative 1/2. Well, remember a minute ago I talked about canceling, how a half cancels with a half, and that gives me negative square root of 3 over 1, or negative square root of 3. Is that what I'm looking for? No. I want negative square root of 3 over 3. So that didn't work. Scribble that out. Let's try this one. Oops. X and y. Do y divided by x. Sorry, I lost my train of thought for a second. Y divided by x is 1/2 divided by negative square root of 3 over 2. The halves cancel. You get 1 over negative square root of 3. And you might say, well, that's not right either. But wait, we have that rule about square roots in the bottom of fractions, right? We need to rationalize this by multiplying by square root of 3 over square root of 3. That gives us 1 times square root of 3 on top. Square root of 3 times square root of 3 on the bottom is square root of 9, which is 3. And then that negative you can just pull out here. And it turns out that is what we're looking for. And that is a 150 degree angle. So 150 degrees is our answer. Could there be a second answer like a lot of the other problems, or could there maybe just be one answer? Well, I'll tell you, the times there's only one answer is usually when it's one of those, one of the main 4, 0, 1, 1, 0, one of those angles. So there is going to be another answer, but it's got to have the same structure as that. The x has to be square root of 3, the y has to be 1/2, and that's right here. The negative changes, but that's okay, because a negative divided by a positive equals a negative, so we're good. This one, if we were to take the time, oh, my app crashed. Give me a second to reload it. I lost the ability to work. Okay, so again, y divided by x, negative 1/2 divided by square root of 3 over 2. You probably don't want to do all this work all over again, but I am, because I don't know, got troubles. Anyway, the halves cancel. You rationalize this. And yes, you do end up with square root of 3 over 3. And that one is a 330 degree angle. Notice this has a 30 degree reference angle, and so does that one have a 30 degree reference angle. So there's something to be said about reference angles. So we check our work on number 24, and there it is. So number 24 is probably the most difficult problem on the whole paper. If you get that, you're good. If you're confused on that, you're confused on the most difficult problem And that's not such a bad thing if you're getting the rest of it. If you're confused on every single problem, you're probably going to want to contact me and I'll work through this paper with some of you. All right, anyway, what's the rest of this paper about? It's the same thing, only you're supposed to give your answer in radians instead of degrees, but it's the exact same thing. So number 26, sine equals -1. Sine is a y value. So where does y equal -1 on the unit circle? Y equals -1. Oh, crud. Let me delete all of this mess. Okay, where does y equal -1 on the unit circle? Only one spot right there, and in radians, that's 3 pi over 2. So there's only one answer. Theta equals 3 pi over 2. Check number 26. There it is. Next one. Cosine equals 1. Well, cosine is an x value, so we're trying to find where on the unit circle does the x value equal 1. And it looks like right here is the only spot. So that is 0 or 2 pi. Now let me read the directions. So it's 0 is less than or equal to theta, less than 2 pi, but not equal to 2 pi. So the only answer we're going to give here is the 0 answer, not the 2 pi answer. And there it is. Look how quickly we're finishing this paper up. Cosine equals -square root of 3 over 2. Well, just like the last problem, cosine is x. So we're trying to find an x value on the unit circle that's -square root of 3 over 2. And that's going to happen twice. Right here is an x value that's -square root of 3 over 2, and right there. By the way, they both have the same reference angle. Isn't that interesting? But anyway, the answers are 5 pi over 6 and 7 pi over 6. So let me write those down. 5 pi over 6 and 7 pi over 6. For number 30, there we go. Last one. This one might be a little bit of a doozy. So cosecant. Cosecant. Okay, let me check my notes because I'm not remembering cosecant. Cosecant is the reciprocal of y. So flip y over. Sorry. 1 over y has to equal 2 radical 3 over 3. Or what might be easier is to flip both of these over. Y over 1 equals 3 over 2 square root of 3. Why did I do that? Well, first of all, y over 1 is just y, and it's going to be really easy to find a y coordinate on the unit circle. Secondly, if I rationalize this by multiplying by square root of 3 over the square root of 3, right? No radicals allowed on the bottom of a fraction. What do I get? I get 3 radical 3 over 2 radical 9, which is 3 radical 3 over 2 times, what is the square root of 9? 3. Those cancel out. So now I'm trying to find a y value that equals square root of 3 over 2. That's fairly easy to find. A y value that equals positive square root of 3 over 2. Right there and right there. Pi over 3, 2 pi over 3. So the answer to this, theta equals pi over 3 and 2 pi over 3. Okay, I said what number 24 was possibly the hardest one on the page. 32 might be up there also. So the trick here was to reciprocate what was given. That's this whole process here. And once you do that, the two answers are easy to find. I just got to check and make sure I'm right. And I am. So some of these are going to be fairly easy and straightforward. Some of these are going to be trickier, more complicated, like that number 24 or like my number 32. So do your best. Have your unit circle handy, just like I did. Scroll up and down or have it next to you on paper or whatever. Contact me if you have questions. Don't forget to check your